Assalamu alaikum, it's Viviane Shwaikani. I'll be explaining chapter 15, Medicinal Drugs, which is the last lesson in this year. In this lesson, we have to define medicinal drugs, we have to identify the therapeutic effect of aspirin, we have to describe the steps of the preparation of aspirin, and finally, we have to determine the yield of preparation of aspirin. Let's introduce our lesson about a history of drugs usage. Actually, using plants and plant substances to treat all kinds of diseases is believed to date back to prehistoric medicine. In ancient Egypt, for example, some documents prove the usage of drugs. Among the medical practices, we list that in Egypt, they used honey to treat, for example, infections. In Greece, at the 5th century before Christ, it was noticed the presence of deadly drugs. And in the Islamic world, around the 9th century, the books of Al-Kindis and Ibn Sina cover a range of drugs. But what is the definition of the medicinal drugs according to the new science? A medicinal drug, and I insisted here to use this adjective, a medicinal drug, because we're not talking about any kind of drug, is a chemical compound or substance that affects the functions of the living organism and is used for therapeutic purposes. Therapeutic, it means علاجية. Now, for any drug used so far, definitely medicinal drug, any drug is made up or contains two kinds of substances. The first one is called the active ingredient, and the second, that might be numerous, they are called excipients. Now, what is the active ingredient? The active ingredient is usually an organic substance. It has a very complex structure. It means it can have more than one functional group, sometimes really more than 3, etc. And it has pharmacological effect. Pharmacological comes from the word pharmacy, صيدلاني. Okay? The active ingredient, after all, is the molecule that that is the essential in a drug, while excipients are simply additives. They assume the forms under which the drug is presented. I will give you an example to understand what is excipients. One example from our daily life is the usage of Panadol for a child. You know that Panadol of child tastes good, even as adults we like to taste it, simply because we add some glucose, some sugar to be tasted good, okay, for the kids. So all this glucose added has nothing to do with the active ingredient. It's just an excipient. It's an additive. Also, its pink color that is attractive has nothing to do with the active ingredient. It's just a kind of excipient to encourage kids to take it. So this is an example to understand what excipients mean. Now, what about drug formulations? It means how the drug is presented. First of all, the drug or a drug can be represented in the form of suppositories, as you can see here, or in form of ointments. Ointments, it means crème in French. It's ointment. This is okay. It can be presented as injection in a syringe. Sometimes it can in the form of tablets. Other time it can be as sprays or syrups. It means liquid in bottles. And finally, it can be formulated in terms of capsule. Now, how to classify the medicinal drugs? According to their pharmaceutical activity, we list 7 classes of drugs. We list, first of all, what do we call analgesics, مسكنات الألم, analgesics. We have anesthetics, المخدر. We have antacids or antacids. These are simply basic substances. Why? Because due to an excess acid in stomach, this cause what do we call stomach burn. We have to administer something basic in order to reduce the excess acidity in the stomach. We have also what is called either anti or anti-inflammatory. You know from biology that it reduces inflammation. We have what do we call tranquilizers, المهدئات. We have antidepressants, مضادات الاكتئاب, that is well known in our days. And finally, we have antibiotics, what is called in Arabic مضادات الحيوية. And pay attention that antibiotics cannot treat viruses, it can treat bacteria. Okay? Now, the single medicine that we have to study this year, it is aspirin. Okay, what is aspirin? Aspirin is also known as acetyl salicylic acid. It's a little bit difficult name, but look, acetyl, you know it from common examples in organic chemistry. What is new is salicylic. And here I'd like to give you an idea about the way you have to write this, because you have I, Y, I. So memorize that this word is symmetrical almost with respect to Y. It means you have I before Y and another I after Y, and I is almost in the middle. Okay, when you have to spell it. So I repeat, aspirin, also known as acetyl salicylic acid, this is the name, the scientific name for aspirin, is one of the most widely used medications in the world. Its use was first recorded around 400 before Christ in the time of Hippocrates. This is the formula of aspirin. Look, aspirin is made up first of all of what do we call benzene molecule or benzene ring, to which we have, look here, it is C double bond OOH, so this is the carboxyl group, and here it is O C double bond OR, so this is what? This is an ester group. Pay attention that the carboxyl group and the ester group has to be consecutive. It means if you decided to try to start drawing one of them here, the second has to be either here or here. So they have to be on two consecutive vertex of the benzene ring. If you find it difficult, keep it for a while. You will be able to memorize it after. Aspirin has many effects. It is known as antipyretic. It means it reduces fever. This is a scientific word. It is analgesic, as we said previously. It reduces pain. It's a kind of painkiller. It is anti-inflammatory. It means it treats inflammations. Now, how to synthesize aspirin in the lab. Here we have to talk about hemi-synthesis reaction of aspirin. Hemi, it means half synthesis reaction of aspirin. We have to explain it. Why? The synthesis of aspirin is simply an esterification reaction. Salicylic acid is treated with acetic anhydride, an acid derivative as you know, in order for a chemical reaction to occur, due to which aspirin and acetic acid are produced. Let's see how this chemical reaction is occurred. But before, let's say that in this reaction, sulfuric acid is used in small amounts in order to catalyze the reaction. So this is a question. It might be a question in an exam that this reaction, in this reaction, we have to use sulfuric acid, as we said, in small amount that serves as a catalyst. Look at the hemi-synthesis reaction of aspirin. First of all, we have to use salicylic acid. What is the formula of salicylic acid? Simply salicylic acid, it is a benzene ring with a carboxyl group and a hydroxyl group. Again, pay attention that the carboxyl and hydroxyl group has to be consecutive. It means on two consecutive vertex of the benzene ring. Salicylic acid is put in presence of acetic anhydride that, according to IUPAC, is called ethanoic anhydride, but you have to memorize both names because you're responsible also for this name, and probably they will use this. And this is the formula of the famous acetic anhydride, as you can see. Here simply, what do you have? You have the hydroxyl group here and you have acetic anhydride. So this is a typical esterification reaction, but that is complete. Why complete? To increase the yield, because we are using acetic anhydride and not acetic acid. Okay, because if we used acetic acid, it would be reversible. So I repeat, we have to use salicylic acid and acetic anhydride, and here the aspirin or acetyl salicylic acid that is obtained. Well, how to think? You know that here we have H from alcohol that comes out, and acetic anhydride will be split. Part of this one here, this part will be attached to this oxygen in order to obtain this ester group. So it is typical esterification starting from salicylic acid, and this is why I said it is easier to memorize the formula of aspirin from this reaction rather from the previous. And we still have what? The remaining part of the acetic anhydride that is here, which is ethanoic acid. Okay, so this is hemi-synthesis of aspirin. One small remark, What about hemi-synthesis? Why didn't we say simply synthesis? Because we have started this reaction from salicylic acid, and we didn't synthesize salicylic acid because it is something that is not required this year in your class. So hemi-synthesis, because we didn't start from zero, we started from an already synthesized salicylic acid. This is to be memorized by heart using structural or condensed structural formulas. Now, what about reflux heating? We saw that aspirin preparation, it's a kind of esterification. Definitely, the reactants has to be put here in a reflux heating and here where aspirin is produced. Now, aspirin, after being produced in this balloon, has to be separated from the reaction mixture, but suction filtration, and it has to be purified by what do we call recrystallization using ethanol as a solvent. Now, a variety of techniques will then be used to assess the purity. Let's see, or let's watch that video in order to know how aspirin is prepared. We are in a lab. So this is salicylic acid. It's a solid. First of all, we have to weigh on a balance the amount that we need. Here is salicylic acid. It is added to this one. And then what do I have to add? I have to add acetic anhydride and a little amount of H2SO4 sulfuric acid that has to serve as a catalyst. Now, since it's an esterification, the mixture has to be put in a balloon and reflux heating will be done. Here we are heated, and look at the condenser here that will appear after a while. This is the condenser that condenses the vapor of substances and to let them be in the reaction mixture. Now I have added water here because aspirin is not very soluble in water, and I have to add a water bath in order to crystallize aspirin, as you can see here. Aspirin is obtained. To separate it from the mixture, I have to filtrate. But here, a filtration using suction or Büchner sometimes used. It's a technique to make it faster than the normal filtration. Again, aspirin is put here and ethanol is added in order as a solvent. Here, the step is called recrystallization. After all, ethanol will be evaporated because it is volatile. And look what we obtained at the end. Okay, again, in recrystallization, we have to put it in a water bath, icy water bath. Here is aspirin that is mixed. Okay, with other substances, we have to filtrate again. And here is aspirin that we are drying out. As you can see, aspirin here is obtained in the form of powder. Here is the active ingredient of aspirin. In industry, we have to add to it excipients to be presented in the form of medicine. Now, how to calculate the yield of the reaction? Here, we have to do a typical exercise to know how. Let's rewrite the given. Suppose we have 5 grams of salicylic acid that are placed in a well-dry Erlenmeyer flask where 8 milliliters of acetic anhydride are then added. At the end of the reaction and after recrystallization, 5 grams of aspirin are obtained. It is required in this exercise to write the equation of the reaction and then to calculate the yield of the preparation, and we have to give here the molar mass of salicylic acid, of acetic anhydride, and that of aspirin, and the density of acid anhydride that is a liquid. For the first question, simply I have copied the reaction I told you to memorize by heart, and again pay attention, it has to be written with condensed structural formulas. Now, for the calculation of the yield, first of all, we have to determine the limiting reactant among these two, or between these two. The ratio of salicylic acid, simply, it is given. We have given the molar mass simply and the mass. So this is the ratio of salicylic acid. What about that of acetic anhydride? Okay, here we don't have the mass. We have the density that will be multiplied by the volume used, which is 8 milliliter. And this is the ratio of acetic anhydride. As you can see, the ratio of salicylic acid is less than that of acetic anhydride, so salicylic acid is the limiting reactant. Now we have to use this amount in order to calculate the number of mole or the mass theoretical of aspirin obtained. This reaction is put again in front of you to be able to calculate it. So calculate the theoretical mass of aspirin to be obtained according to stoichiometry. N of salicylic acid, as we can see, it's equal to N of the aspirin form that is here. That is that not much. What about N of aspirin? Okay, here which N I repeat, or which mass here? It is the theoretical mass. It's 6.52 gram. Now applying the formula of the yield. What is the yield? The yield is equal to the actual mass obtained experimentally, that is given in the exercise as 5 gram, over the theoretical mass, that is 6.52 gram. So the yield times 100 will be 76%. Thanks for watching and good luck in the exams.